Hey guys, we're going to talk about heat transfer. This will be a review for a bunch of y'all, but these are things that you have to know. What is heat versus temperature? We talked about that in the last video to some extent. Heat is energy, and energy can be transferred from things that have a higher temp to a lower temp. Always goes from hot to cold. This is the thing. If heat is transferred and you have this high to low temp, then what's really going on here is you have a lot of you have some object that has very high high kinetic energy in all of its molecules, and that kinetic energy gets transferred. So if I heat a pot of water on the stove, the bottom of the pot, all of its molecules are moving very fast, and it gets very hot. I can probably still touch the top of the pot for a while because that transfer process takes time. I kind of see it as the domino effect, where these molecules here are starting to move faster, and then it makes these right next to it move faster, and then these molecules here next to those start moving faster, and it takes time to get all the way to the top. So if things are touching, this is how heat can transfer. We call it conduction. Okay? The medium itself does not move, so it's not like the metal down here travels upwards. That's not what happens. It's the energy moves. And things always get transferred from hot to cold. Now, question. Does heat rise? Yes or no? True or false? Does heat rise? The answer to that question is no, it's false. I posed this question to my AP1 students at the beginning of this year, and I had a lot of people who were very surprised, and some people acted like they wanted to jump out of the Zoom meeting and strangle me. Heat does not rise. Heat is purely an energy transfer process. Hot air rises. So it's okay to say hot air rises. If you have a heater in the first floor, it will heat the air right next to it. That air has higher kinetic energy. It will suddenly have lower density. It will rise up here, whereby it will lose all of its energy to its surroundings at the top. It will fall back down. Cold air is more dense, and it falls, and then you get this little cycle. We call this convection, where you get convection currents. This explains a lot of our weather phenomena. This explains why hurricanes do what they do, why thunderstorms act the way that they do. And this is a thing. But yes, it's not correct to say heat rises. You can say hot air rises. That's okay. And so we call these convection currents. There you go. Of course, we have heat transfer by radiation. This is where there is no contact at all. And I think about this during the wintertime when I go out and get in my car. It's very cold outside, and I get in my car, and my car is nice and warm. It's because it's been heated from the electromagnetic radiation from the sun. And so things are not directly touching, but this is a thing. So, make sure you understand these terms, have some idea about what they mean. Coffee, 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 coffee. Oh, yes. Always thinking about coffee, guys. What is it? Conduction, convection, radiation. There's a little heating element in the bottom, and actually I found that the coffee at the bottom can be warmer than at the top. You can get convection currents set up in this coffee pot, though, because you have your heat at the bottom, so you can actually get currents going. Yeah. Okay, so let's talk about heat currents. And how does heat move? Heat is not heat transfer, I should say, is not an instantaneous process. It does take time, and so if you have a hot side here and a cold side here, and you have some sort of a bar, you can get heat transfer to take place, and it has a direction. Okay. Heat is Q. And I've never liked that, but that's the way it is. Heat is Q. Heat is another word for, well, let me just ask this. Q is measured in J, which is joules. So do you remember what joules means? What are joules? Joules are the unit for what? Joules are the unit for energy. And so heat, the symbol is Q, and that has to do with energy. Energy per unit time. We'll call this a heat current, joules per second. It always goes from high temperature to low temp. There are different units. We usually use joules per second, but you can also see it in calories per second and BTUs per hour. Calories is an interesting unit. I usually talk about how calories shows up in the grocery store when you're talking about food or you're talking about losing weight or being more energetic or what have you. We talk about the amount of calories in our food. And the calorie is simply another unit for energy. And so I don't usually like to talk about foods in terms of bad or good. They're high caloric density or low. And a big problem in this country is we do not move enough, we do not expend enough energy, and therefore we have we have a lot of high caloric density foods that are readily available. And this is a problem for us because we tend to store all that energy that we don't use as fat. Now, thermal conductivity. We're getting into engineering here, and you'll see problems like this. They're not super common, but they can happen. Of a material, so this is sort of material science. We're talking about windows, we're talking about walls, things like this. Civil engineers care about these things. And so the equations that you'll see involve these different variables. H is heat current. A is the surface area. Usually you're talking about things that have very regular surfaces. They're usually squares or rectangles. Small delta T, the difference in temperature. And then the thickness. So a lot of times these equations are used when they're talking about heat transfer through windows. And so these equations, this one right here, we will use sparingly, but you may see it. Okay, and we can solve for K, it's little k. We call that the thermal conductivity of a particular, stuff, whatever it may be. And so when we solve for that, this is what you get: a joule per second times a meter divided by meters squared. So sometimes you'll see older units, BTUs, areas maybe in square feet. You may have to convert. That's annoying. Converting is an annoyance. Wouldn't it be nice if we all used one system? I don't know, like the metric system maybe. Wouldn't that be so nice? BTUs you may have seen if you purchase like a window unit, which is a little window air conditioning unit from Lowe's or Home Depot or something. Usually they're rated in BTUs, which stands for British Thermal Units. That's a thing. Different thermal conductivities of stuff. We like to use copper for all of our wires. We also can use copper to cook things with. Copper is a very good conductor. That's a thing. And of course, it'd be good to know what what things are good conductors of heat and electricity and what aren't. There you go. Here's an example of a problem. You have a large glass window. It has dimensions. And they tell you there's a temperature difference between inside versus outside. how many joules of heat pass through this window in 1 hour. 1 hour we'd have to convert to seconds. And so you can use this equation here and run through the calculation. And this is a lot of number crunching. If I've done my math right. There you go. The big M here, go away. The big M is megajoules. Okay, so it just depends on whether you're using joules or using megajoules. The number was so big that I ended up using megajoules. Okay, so there you go.